Hello dear students, in this video I'll be solving a past paper for A levels 2021. So this paper was for 75 marks. So let's start. The first question says solve the equation ln of x cube minus 3 equals to 3 ln x minus ln of 3. Okay students, so now let us discuss few things, that is properties of log x, power law. If I have a into ln of x, using power law I can write this thing as ln of x to the power a. All right, let me copy down the question. We have ln of x cube minus 3 equals to 3 ln x minus ln 3. So this 3 ln x using this property, since, and then since ln of a minus ln of b, this property is ln of a by b. So using these two properties, I can rewrite this question as ln of x cube minus 3 equals to ln of x to the power 3 minus ln of 3. Now students, this thing is ln of a minus ln of b. So I can rewrite this thing as ln of x cube divided by 3. Okay. And left hand side we have ln of x cube minus 3. So now both the side we have ln. So now I can compare x minus 3 equals x power 3 divided by 3. All right. Okay. So now cross multiplying this 3 over here. Take this 3 over here. So we will get 3x cube minus 3 3s are 9 equals to x cube. Then taking like terms, one side we have 3x cube minus x cube equals to 9. Okay. So we basically get 2x cube is equals to 9, or x cube is equals to 9 by 2. And therefore x is equals to 9 by 2 to the power of 1 by 3. So when you take this power to left hand side, it will become reciprocal. All right. So this value is nothing but 1.65. Okay. You can do this in your calculator. You'll get 1.65. Moving on to next question. Question number 2, it says the polynomial ax cube plus 5x square minus 4x plus b, where a and b are constants, is denoted by p of x. So let us write the given data. We are given that p of x is equals to ax cube plus 5x square minus 4x plus b. All right, where a and b are constants. It is given that x plus 2 is a factor of p of x, right? So we'll write the given data over here. Since x plus 2 is a factor, right? So what do you mean by factor theorem? If x plus 2 is a factor, then if I divide this p of x by x plus 2, the remainder will be 0, right? So equate this factor to 0, x plus 2 equals to 0, we get x equals to minus 2, right? So if I plug in this x equals to minus 2 in p of x, therefore p of minus 2 should be equal to 0. That is what the factor theorem says. Okay. So now here we have two unknowns. What they have asked, find the values of a and b, is a factor of px, and that when p of x is divided by x plus 1, the remainder is 2. Okay, so students, we don't have to divide it physically, right? We have to use these two theorems, factor theorem and remainder theorem. Next given set of data is, since x plus 1, when p of x is divided by x plus 1, the remainder is 2. So that means p of minus 1 should be equal to 2. Okay, so two conditions are given to us. This is first condition and this is second condition. So now we can write here p of minus 2 should be equal to 0. So what is p of minus 2? Just plug in minus 2 over here, plus 5 into minus 2 square minus 4 into minus 2 plus b equals to 0. Okay, now minus 2 cube is nothing but 8. So this becomes minus 8. All right, then 5 minus 2 square is 4. 5 4 is 20. Minus into minus becomes plus. So this becomes plus 8 plus b equals to 0. Right? So we finally have b minus 8a is equals to minus 28. This is our equation 1. Okay. Now from second set of data, p of minus 1 is equals to 2. So we have p of minus 1 is equals to 2. Therefore, just plug in x is equals to minus 1 over here. So we'll get a into minus 1 cube plus 5 into minus 1 square minus 4 into minus 1 plus b equals to 2. All right. So minus 1 cube is minus. So this is minus a. Minus 1 square is positive 1 into 5 is positive 5. Minus times minus is positive. So this becomes 4 plus b equals to 2. And therefore I can write b minus a is equals to 2 minus 9. 5 plus 4 is 9 and 2 over here. So if I take 9 to right hand side, it will become 2 minus 9. And finally, we have b minus a is equals to negative 7. This is equation 2. Okay. Now we can write from equation 1 and 2. Okay. We have b minus 8a equals to minus 28. And we have b minus a is equals to minus 7. So if I subtract, sign will change. This will become negative, positive, positive. So b minus b cancels out. Minus 8 plus a is negative 7a. Minus 28 plus 7 is negative 21. Therefore, we get a is equals to positive 3. Okay. Now plug in the value of a in equation 1. Right. Now here I can write put a equals to 3 in equation b minus a is equals to negative 7. All right. So here we'll get b minus of 3 equals to minus 7. Therefore, b is equals to minus 3 will come this side, minus 7 plus 3, b equals to minus 4. That's your answer. So a is 3, b is minus 4. Okay. Moving on to next one. Question number 3. Right. So we are given that by first expressing the equation tan of x plus 45 degree equals to 2 cot x plus 1 as a quadratic equation in tan x, solve the equation for x greater than 0 degree and less than 180. Okay. So how to solve this? We'll be using trigonometric identities, that is tan of a plus b. Tan of a plus b is tan a plus tan b. Whole thing divided by 1 minus tan a tan b. Okay. Then we'll be using the fact that cot x can be written as reciprocal of tan x. Okay. So now let me copy the question. It says tan of x plus 45 degrees is equals to 2 cot x plus 1. So now here I can apply tan a plus b. So this will become tan x plus tan 45 divided by 1 minus tan x into tan 45 using the identity of tan a plus b. Then on RHS I can write 2 since cot x is 1 by tan x. So I can change cot x plus 1. All right. Now taking the LCM over here, this is 1. So LCM is tan x. So this thing is 2 plus tan x. Okay. Divided by tan x. Now tan 45 degrees. I can write here. This is my given set of information since tan 45 degrees is equals to 1. Right, students? So I can write here tan x plus 1 divided by 1 minus tan x into 1, which is tan x only. Tan 45 is 1. Now I can cross multiply. So I'll get tan x plus 1 multiplied by tan x is equals to this whole thing, taking it this side and this one, taking it this side. So 2 plus tan x multiplied by 1 minus tan x. Okay. So now if I open the bracket, I'll get tan x into tan x, which is tan square x, plus 1 into tan x is tan x, is equals to 2 into 1, 2. 2 into minus tan x is minus 2 tan x, plus tan x into 1 is tan x, plus into minus minus, tan x into tan x is negative tan square x. Okay. Now I can take everything to left hand side. I'll get basically tan square x plus tan x. Then this minus 2 tan x plus tan x is negative tan x. So when it will come to left hand side, it will become positive tan x. Then positive tan square x minus 2 equals to 0. Okay. So I've skipped one step over here. This minus 2 tan x plus tan x is negative tan x. Then negative tan x will go to left hand side, it will become positive. So tan square x plus tan square x is 2 tan square x, plus tan x is 2 tan x, minus 2 equals to 0. Now I can take 2 common. So I'll get tan square x plus tan x minus 1 equals to 0. So therefore we got quadratic equation in terms of tan x. So tan square x plus tan x minus 1 equals to 0. Right, students? Let's see the question again. It says solve the equation for x from 0 degree to 180 degree. 0 degree to 180 degree, that means what it means is tan is positive in this is 0 degree and this is 180 degrees. This is 90 degrees. This is 270 degrees and then this is 360. So x lies in first quadrant and second quadrant, right? So in first quadrant, tan is positive. Okay. In first quadrant, tan is positive. In second quadrant, tan is negative. So if tan is negative in second quadrant, we have to consider both positive and negative values. All right. So if I solve this, what I basically will get, I can assume x is equals to tan theta. Okay. X is equals to, or rather, y is equals to tan x. Okay. If I assume y equals to tan x, basically I have y square plus y minus 1 equals to 0. Therefore, I can write y is equals to minus b. B is negative 1 plus minus underscore under root b square. B square is 1 minus 4ac. So 4 into minus 1. C is minus 1. Okay, the coefficient. So A is 1, B is 1, C is minus 1 divided by 2A. And A is 1. Therefore, we have y equals to plus minus under root 5 divided by 2. Okay. So now from here, I can say two values of y are y equals to minus 1 plus root 5 divided by 2 and minus 1 minus root 5 divided by 2. Now we had assumed y equals to tan x. Therefore, tan x is equals to minus 1 plus root 5 divided by 2. Okay. And tan x is equals to negative 1 negative root 5 divided by 2. So from here I can say tan inverse of minus 1 plus root 5 by 2, and from here tan inverse of minus 1 minus root 5 divided by 2. So here we'll get x is equals to, and here also x is equals to. So you can plug in these values in your calculator and get the values. So for tan inverse this thing, you'll get 37.18 degrees. Okay. Here this negative you can take common, then tan inverse of minus theta is pi minus theta. Okay. Since tan inverse of minus theta is pi minus tan inverse theta. Okay, we'll be using this result. So whatever answer you're getting for this, you have to subtract it from 180. Therefore, you'll get 121.72 degrees. All right. So in your calculator, you plug in tan inverse of 1 plus root 5 by 2. And then whatever answer you're getting, subtracted from 120 or 180. Okay, because it is given to us that x is from 0 to 180. All right. Moving on to next question. Question number 4 says the variables x and y satisfy the differential equation. It is given that y equals to 4 when x is equals to pi. Solve the differential equation, obtaining an expression for y in terms of x. All right. So let us first write the given equation of differential equation. Dy by dx equals to y sine x. Now we know that the solution of differential equation involves variable separable. So what we can do is separate the variables. So we'll write dy by y. I can take this y over here and all the x terms to right hand side. Sin x divided by 1 minus cos x. Okay. So into dx. Now I have to integrate both the side here with respect to y and right hand side with respect to x. Now, since integration of 1 by x dx is ln x, all right, so here we'll get ln y equals to. Now, right hand side integration, we see that it is of the form f dash of x divided by f of x integral dx. Answer is ln of f of x. So if the derivative of denominator is present in numerator, this is the form, right? Answer is ln of f of x. So now 1 minus cos x, right? What is the derivative of 1 minus cos x with respect to x? 1 derivative is 0, minus cos x derivative is minus, cos x derivative is again negative sin x. So negative negative becomes positive, we have sin x. Okay, now sin x is present in numerator. Therefore, answer for this integral will be ln of 1 minus cos x plus ln c. Okay, the constant of arbitrary constant in indefinite integral, right? So now we have to find the value of this constant c. So for that we are given the condition when y equals to 4, x is equals to pi. So now plug in the condition and write this thing as equation 1. This is our general equation, equation 1. Now y equals to 4, so ln 4 is equals to ln of 1 minus x is pi cos pi plus ln c. Now cos pi, since cos pi is equals to minus 1, cos 180 is minus 1. So therefore we have ln 4 is equals to ln of 1 minus minus 1 plus ln c. And finally we have ln 4 is equals to ln of 2 plus ln c. Then I can take ln 2 to left hand side, ln 4 minus ln 2 equals to ln c. Now ln a minus ln b is ln a by b. So this will become ln 4 by 2, right? Since ln a minus ln b is equals to ln a by b. Using this property, I've written this thing equals to ln c. Okay, so 4 by 2 is nothing but 2 only equals to ln c. So we got the value of ln c as ln 2. Okay, now putting this value over in this equation, plug in ln c equals to ln 2 in this final equation, right? Put the value of ln c in equation 1, which is this equation 1. So we get ln of y is equals to ln of 1 minus cos x plus ln c is ln 2. Okay, so now here we have ln a plus ln b. Now since ln a plus ln b is equals to ln of a into b, so using that property I can write this thing as ln of 1 minus cos x into 2. Okay, ln a plus ln b is ln a into b, and here we have ln y. So therefore I can compare, cancelling ln both the sides, we have y equals to 2 into 1 minus cos x. So students, this is your answer, y in terms of x. Okay, let's see the question once again. Yeah, expression for y in terms of x is this. All right, now they have asked sketch the graph of y against x for x belonging from 0 to 2 pi. All right, so we got that y is equals to 2 into 1 minus cos x is the relation between x and y. So we'll draw a table over here, and I can split this interval from 0 to 2 pi in terms of quadrants. Okay, so this is x value and this is y value. So x is greater than 0, right? So we'll take when x is 0, y is how much? Y is equals to 0, because cos 0 is 1, 1 minus 1 is 0, 2 into 0 is 0. Then I can take 90 degrees. Okay, so cos 90 is again 0, so 1 minus 0 is 1, 2 into 1, 2. Then I can take 180. Okay, so cos 180 is minus 1, so 1 minus minus 1 is 2, 2 2 is 4, so y is 4. Then we have 270. So 270 means cos 270 is 0, so 1 minus 0 is 0, 1, so 2 into 1 is 2. Then cos 360 is again 0. Okay, cos 360 is 1, so 1 minus 1 0, 0 into 2 is 0. So students, we got this thing, values of x and y, so we can plot these values on grid. Let us draw here a rough sketch. So this is my y-axis, this is my x-axis, where on x-axis we'll plot the angles 0 degrees, 90 degrees, 180 degrees, 270 degrees, and 360 degrees. Then y varies from 0 to 4, right? So 0, 1, 2, 3, 4. 3, 4. Okay. Now we will plot these points. Now mind it, here x is not equals to 0 and x is not equals to 2 pi. Okay. So we have to consider greater than. So when x is greater than this, so at x equals to 0, y is 0. Okay. At this point. So we don't have to touch this point. And 90 it is 2. So 90 it is 2. Okay. Then 180 it is 4. So at 180 it is 4. Then 270 it is again 2. So y is 2 here. Then 360 it is 0. But we don't have to consider this point. So slightly from this, okay, I can join this and approaching like this. I can keep till here. Okay, you don't have to join it with 0 because x is not equals to 0 and x is not equals to 2 pi. Okay, so from 0 to 180 it is an increasing function. From 180 to 360 it is a decreasing function. So this is the graph. Okay, moving on to next question. Question 5 says express under root 7 sine x plus 2 cos x in the form r sine x plus alpha, where r is greater than 0 and alpha lies between 0 to 90 degrees. 0 and 90 not being inclusive, state the exact value of r and give alpha correct to 2 decimal places. So students, first of all, I should know that a sine x plus b cos x is nothing but r times sine x plus alpha, where r is under root a square plus b square. Okay, so comparing this given equation, root 7 sine x plus 2 cos x, okay, equals to r sine x plus alpha. So from here I can say a is equals to root 7 and b is equals to 2. B equals to 2 on comparing these two equations, right? Therefore, r is equals to under root a square, that is root 7 whole square, plus b is 2, 2 square. We have under root 7 square is 7, 2 square is 4. So we got under root 11. Therefore, r is equals to under root 11. That's your answer. Next thing is we have to find alpha, right? So since this r is nothing but if I open this r into sine of a plus b, right? So we will get this thing x cos alpha and x sine alpha. Okay, so tan alpha is defined as b over a. All right, because b is r sine alpha and a is r cos alpha. Okay, so if I divide both of them, r and r will cancel. Sine by cos is tan. So tan alpha is b by a. So from here I can write tan alpha is equals to b is 2 and a is root 7. Therefore alpha is equals to tan inverse of 2 by root 7. So alpha, you can plug in this value in the calculator. Therefore you'll get alpha is 37.09 degrees. That's your answer for alpha. Okay, students. All right. Moving on to next one, part B. Okay. So it says hence solve the equation. So this is part B. Root 7 sine 2 theta plus 2 cos 2 theta equals to 1. Okay. All right. So it is given to us that this thing is equals to 1. Fine. So we know that this under root 7 sine 2 theta plus 2 cos 2 theta, right? This thing we got it as under root 11 sine of x plus 37.09 degrees. All right. So this x was when here we had x, right? When the angle is x, here also it is x. But if it is 2 theta, so I can write here, I can change this x to 2 theta. Okay, whatever angle is here, same angle has to be here. So therefore, LHS equals to this. So now I can write, therefore, under root 11 into sine of 2 theta. Okay, sine of 2 theta. This thing is 2 theta plus 37.09 degrees is equals to 1. Right, we are given that it is equals to 1. So now I can take this root 11 to right hand side. So sine 2 theta plus 37.09 degrees is equals to 1 divided by under root 11. So now 2 theta plus 37.09 degrees, this thing is equals to sine inverse of mine this 1 by under root 11. So this value is 17.55 degrees. So we finally got 2 theta plus 37.09 degrees is equals to 17 point this thing. Okay, so now we see here that sine of this is important. Okay, sine of some angle, it is positive, right? So sine is positive in which quadrant? Sine is positive in first quadrant and it is positive in second quadrant, right? Sine is positive, y and x. So sine is positive in first quadrant and sine is positive in second quadrant. And that is what the domain of theta is given to us, right? Theta lies in first and second quadrant. So we will have two sets of answer. There will be two values of theta, one for first quadrant, another one for second quadrant. Okay. So solving it further, we have from here, right? So this is one equation. Second equation, we will get 2 theta plus 37.09 degrees. Okay, this is the complete angle equals to 180 minus 17.55 degrees. Okay, so 180 minus 17.55 degrees is nothing but 162.45 degrees. Okay, 2 theta plus 37.09 degrees. This is equation 2. So students, how I got 1? It is just sine inverse of 1 by root 11, which is this. Okay, so this value is for the first quadrant. Then second quadrant, from first quadrant to second quadrant, how do you get? If you know the acute angle, 180 minus theta, right? 180 minus theta gives you in second quadrant. So this is the second value in the second quadrant. Now we have to solve for theta in both the equations for first one. Okay, so from 1, I can write 2 theta plus 37.09 degrees is equals to 17.55 degrees. All right. So from here you can write 2 theta is equals to 17.55 degrees minus 37.09 degrees. Okay. So theta is equals to 17.55 minus 37.09 degrees whole divided by 2, which is equals to minus 9.77 degrees, right? So you are getting theta is equals to minus 9.77 degrees. Is this defined? No. The domain for theta is greater than 0 and 180. That means I have to convert this into what? This is minus, right? Minus means in the fourth quadrant, right? So if I add 180 to this, I'll get into, this is minus 9.77. Okay, fourth quadrant. If I add 180 to it, I'll reach in second quadrant. So therefore, theta is equals to 180 plus 9.77 degrees. So now this is minus, right? Minus. So we get 170.2 degrees. This is first value of theta, which is in second quadrant. Okay. Now from equation 2, we have 2 theta plus 37.09 degrees is equals to 162.45 degrees. Therefore, 2 theta is equals to 162.45 minus 37.09. Therefore, theta is equals to 125.36 divided by 2. And that is equals to 62.68 degrees. Or I can say theta equals to 62.7 degrees, rounding it off to 1 decimal place. So that's your answer. Okay. Moving on to next one. Question number 6, it says, let f of x is equals to 5a divided by 2x minus a into 3a minus x, where a is a positive constant, express f of x in partial fractions. So let us write the question, 5a divided by 2x minus a, 3a minus x. So the partial fraction for this, the denominator is linear multiplied by linear, so it will be 2x minus a plus b divided by 3a minus x. So 5a divided by 2x minus a, here we have 3a minus x. So if I cross multiply this, I'll get 3a minus x plus b into 2x minus a, and the LCM is 2x minus a multiplied by 3a minus x. So now I can cancel these two terms, and therefore we got the equation 5a is equals to a into 3a minus x plus b into 2x minus a. All right. So now we have to solve for a and b. Put x is equals to 3a, right? So we'll get 5a is equals to a into 3a minus 3a plus b into 2 into 3a, okay, minus a. So this becomes a into 0 plus b into 6a minus a is 5a, 2 3s are 6, equals to 5a. Therefore, we got b as 5a divided by 5a, which is equals to 1. Okay, therefore we got b equals to 1. Now, in order to find for a, okay, you can plug in x is equals to a. So put x is equals to a. We have 5a is equals to a into 3a minus a plus b into 2a minus a. All right. So from here, what we will get is 5a, 3a minus a is 2a plus b into a. 2a minus a is a. Now we know the value of b as 1. So we finally get a into 2a plus b is 1. So 1 into a is a only. 1 multiplied by a equals to 5a. Therefore, I can write 2a into a is equals to 5a minus a, and therefore a is equals to 4a divided by 2a, which is equals to 2, right? So we got the value of a is equals to 2. And so the final answer, a is 2, b is 1. So final answer is 2 divided by 3a minus x. Okay, 2x minus a. This thing is 2x minus a plus b is 1 divided by 3a minus x. So this is the partial fraction. That's your answer. Moving on to part B, it says, hence show that integration from a to 2a f of x dx is equals to ln 6. So we got f of x. This is our f of x. So I can put it here, integral. This is definite integral a to 2a. F of x is 2 divided by x minus a, 2x minus a, plus 1 divided by 3a minus x, whole integral with respect to dx. All right. Now using the properties of integral, I can split this and write a to 2a, 2 divided by 2x minus a, integral dx, plus integral a to 2a, 1 by 3a minus x dx. All right. So now here this is of the form, the derivative of denominator is present in numerator. 2x minus a derivative is how much? It is 2. So answer for this is ln of 2x minus a. A is a constant over here. Okay. So under the limits a to 2a, right? Then we have 1 by 3a minus x. 3a is a constant. So if I differentiate the denominator, derivative of 3a minus x is minus 1. But in numerator, we have 1. So we'll multiply with minus 1. 3a minus x derivative is minus 1, right? So minus 1 will come here and then answer will become ln of 3a minus x under the limits 0 to 2a. I mean a to 2a. Okay. So now upper limit minus lower limit, x is 2a, so into 2a minus a minus lower limit ln of 2 into a minus a minus, then we have ln of 3a minus 2a minus ln of 3a minus a. Solving this, 2 into 2 is 4, right? 4 minus a is 3a minus ln of 2a minus a is a minus ln of 3a minus a is nothing but ln of a minus ln of 3a minus a is 2a. Now using the property of ln a minus ln b is ln a by b. So I can write this thing as ln a divided by ln b minus, using this property ln a minus ln b, I can write this thing as ln a divided by 2a. So I can now cancel a and a. So we finally have ln of 3 minus ln of 1 by 2. So again, I can apply the property of log, that is ln a minus ln b, which is ln a divided by ln b. So this 2 will go up. So we finally have ln of 3 into 2 divided by 1, which is ln of 6. Hence proved. Moving on to next question. It says two lines have equations r equals to 1, 3, 2. This is the point, right? This is the position vector of the point, and this is the vector 2, minus 1, and 3, where s is a scalar quantity, any scalar. So this is the equation of a line in vector form. So let us write line 1. We have to show that the lines are skew. Skew condition means they are neither parallel, right? They are neither parallel nor do they intersect, right? So we can say if this is a vector associated with line A. So let me write the equations first. So we have finally r is equals to 1 I cap plus 3 j cap plus 2 k cap. This is the point, plus s is a scalar multiplied by 2 I cap minus j cap plus 3 k cap. Okay, so the vector associated with first line is this. Let me call this as vector A. Then next we have is the equation of line 2. We have r equals to 2 I cap plus 1 j cap, right? 2 I cap, 1 j cap plus 4 k cap. This is the point, plus t multiplied by 1 into I cap minus j cap plus 4 k cap. Okay, so here the B vector associated with line B, line 2 is this vector. So clearly we can see that vector A is not a scalar multiple of B, right? Clearly vector A is not a scalar multiple of vector B, isn't it? See, A is 2 minus 1, 3, B is 1 minus 1, 4, right? So A cannot be written as some number times B, isn't it? See this vector A and B. This is 2 minus 1, 3, this is 1 minus 1, 4. Nothing is common between them, and therefore we can say the two lines are not parallel. Okay, so the two lines are not parallel. So first condition of any two lines being skew lines is proved. We have to prove the second condition, they should not intersect also. Okay, so in order to prove that, I have to write the parametric equation for both, right? Second condition is they do not intersect, and for that I need to write the parametric equation for both the lines. So if I write parametric form for both the equation, I'll get x is equals to 1 plus 2s, y is equals to 3 minus s, and z is equals to 2 plus 3s. Okay, then for second line we have x is equals to, how I'm writing this is from here, 2 plus t. Okay, then y is equals to 1 minus t. All right, then z is equals to 4 plus 4t. So now if they intersect, we know that if two lines intersect, their corresponding x and y coordinates will be equal, isn't it? So I can equate x coordinate, I can write here equating x and y coordinates, right? So we have 1 plus 2x is equals to 2 plus t. So we get 1 plus 2s is equals to 2 plus t. So from here I can write 2s minus t is equals to 2 minus 1. Therefore we have 2s minus t is equals to 1. This is equation 1. Then from here I can write for y, right? I can equate y and write 3 minus s is equals to 1 minus t. Therefore, I can write this thing as 3 minus 1 is equals to s minus t, or s minus t is equals to 2. This is my equation 2. All right. Now, from equation 1 and 2, I can write 2s minus t is equals to 1 and s minus t equals to 2. If I subtract these two equations, this will be minus. So minus t plus t cancels out. 2s minus s is s. 1 minus 2 is minus 1. So we got s is equals to minus 1. And when s is equals to minus 1, we'll get t is equals to. So s is minus 1. So minus 1 will go here. It will become 3. T equals to minus 3. We get t equals to minus 3. Now we have to plug in the values of s and t in these values, right? S and T. So for line 1, R1 we have, and this is for line 2, R2. Right? The parametric form which we have written, we have x is equals to 1 plus 2s, y is equals to 3 minus s, and z is equals to 2 plus 3s. So now we have to plug in the values of s and check if the coordinates are equal. If it is equal, then they will intersect. If it is not equal, then they will not intersect. Right? So here we have 2 plus t, we have 1 minus t, and z is equals to 4 plus 4t. So if I put s is equals to minus 1, so 1 minus 2 is minus 1. Here 3 is minus 3. So 2 minus 3 is minus 1. So x coordinate is same. Then 3 minus minus 1 is positive 4. 1 minus minus 3 is again positive 4. So this is also equal. Then 2 minus 3 is minus 1. 4 minus 12, right? 4 3s is 12. So this is minus 8. So z is not equal. Therefore, we can say that these two lines do not intersect. Okay, and hence, therefore, the lines are skew. Okay, here clearly z coordinate is not equal. Okay, so that means both the points are different. Intersection means there will be a common point. Okay, so here z coordinate is different, therefore they do not intersect as well. Moving on to next question. It says find the acute angle between the directions of the two lines. So the angle between two lines will be the angle between the vectors. Okay, so these two lines, they have an equation in terms of vectors. Okay, so the vector associated with line 1 and 2 is a and b. So if I know the angle between these two vectors, that will be the angle between the lines. So what is vector a? Vector a is given to us as 2 minus j plus 3k. 2 minus j plus 3k, and vector b is given to us as 1 minus j plus 4k. 1 minus j plus 4k. Right, students? So here we know that the angle between two vectors is defined by a dot b is equals to magnitude of vector a into magnitude of vector b into cos theta. So a dot b, we have 2 I cap minus j cap plus 3k cap. Here I cap minus j cap plus 4k cap, this is dot product, is equals to magnitude of a. Magnitude of a is 2 square plus minus 1 square plus 3 square into magnitude of b. Magnitude of b is 1 square plus minus 1 square plus 4 square into cos theta. All right. So this 2 into 1 is 2, minus 1 into minus 1 is positive 1, 3 into 4 is positive 12, is equals to under root 2 square is 4 plus 1, 5 plus 9. So under root 14. All right. And here we have under root 1 square plus 1 square is 2 and 16. So under root 18 into cos theta we got. Okay. So this thing is 15 equals to under root 14 into under root 18 cos theta, and therefore I can write this thing as 15 divided by under root 14 into under root 18 equals to cos theta. Therefore I can write theta is equals to cos inverse of 15 divided by under root 14 into under root 18. So this value is, if you put this in calculator, you will get 19.106. That's the angle between the two lines. Okay, so the concept is the angle between two lines will be the angle between the vectors associated with these two lines. Okay, moving on to next question. We have complex number u and v are defined by u equals to this and v equals to 3 plus I. Find u by v in the form x plus iv. So u by v, I can write it as minus 4 plus 2i divided by 3 plus I. So here if I rationalize this, I have to multiply by the conjugate 3 minus I divided by 3 minus I. Okay, so below will be 3 square plus 1 square. Then numerator will be minus 4. This is minus 12 plus 4i plus 6i minus 2i square. Okay, cross multiplication. So minus 4i plus minus 4 plus 2i multiplied by 3 minus I is this. So we get u by v is equals to minus 12 and this will become positive 2. So we have minus 10 plus 10i divided by 3 square plus 1 is 10. So this thing is minus 1 plus I. Okay, so u by v, we got it as minus 1 plus I, where x and y are real. Okay, so therefore u by v is nothing but minus 1 plus I, where x is equals to minus 1 and imaginary part is also 1. All right, moving on to next question. Hence, express u by v in the form r into e power I theta, that is exponential form, where r and theta are exact. Okay, so we got u by v is equals to minus 1 plus I. Now we know that r is nothing but the magnitude. So r is nothing but under root minus 1 square plus 1 square. Okay, so r we got it as under root 1 square plus 1 square, which is under root 2. So r is under root 2 and then theta. So here tan theta, which is the argument, is defined as b over a. So here a is minus 1, b is positive 1, right? This is b. So a is negative 1, b is positive, right? So this lies in basically second quadrant. Okay, so tan theta is equals to 1 divided by minus 1. Therefore, theta is equals to tan inverse of minus 1. So we got theta equals to minus pi by 4. Okay, but we know that the principal argument is always positive. So in second quadrant, it is pi plus theta. So pi plus minus pi by 4. So we have theta equals to 3 pi by 4. Okay, therefore, I can write in the form u by v equals to r is root 2 e power I into theta is 3 pi by 4. That is your answer in exponential form. I hope it is clear to you. Moving on to next question. It says in an Argand diagram with origin O, the points A, B, C represent the complex number u, v and 2u plus v respectively. State fully the geometrical relationship between OA and BC. All right. So in Argand diagram, let's draw a rough sketch. You know that this is imaginary axis and this is real axis. This is negative real axis. This is negative imaginary axis. This is origin 0, 0. So we have to plot, right? U is given to us as minus 4 plus 2i. V is given to us as 3 plus I. Okay, then 2u plus v will be minus 8 plus 4i, right? 2 into u plus v, 3 plus I will give me minus 5 plus 5i. So 2u plus v is equals to this. Now we will plot u equals to minus 4 plus 2, right? So minus 4 plus 2 is in second quadrant. So real is minus 4 and then 2. So somewhere here it will lie. So minus 4 comma 2. This is my point u, right? The number, imaginary number u. Then we have 3 plus. So x is 3 somewhere here in the first quadrant and 1. So this is my v. 3 comma 1. All right, then we have 2u plus v. So this u is denoted by a, v is denoted by b, and c is represented by 2u plus v. Okay, so let me call this as point a, this is point b, whose coordinates are 3 comma 1, and c is minus 5 comma 5. So minus 5 comma 5 will be somewhere here, right? Minus 5 comma 5, this is point c. Now join everything. Okay, so now they have asked what is the relationship between OA and BC. So where is OA? From origin, this is OA, and what is the relation between BC? So this length is BC. Okay, so I have to calculate what is OA first. OA means magnitude of OA. Magnitude of OA is nothing but under root. OA vector is minus 4 square plus 2 square, which is 16 plus 4, that is under root 20. Okay, now BC, magnitude of BC is nothing but, if I want to write the vector of BC, it will be 3 minus minus 5, which is 8, right? X2 minus x1. So 3 minus minus 5 is positive 8 square plus y2 minus y1 whole square. So 1 minus 5 is negative 4 square. Distance formula basically. Okay. So 8 square is 64 plus 4 square is 16. We got under root 80. Under root 80 can be written as 2 root 20. Okay. So therefore, from here I can say BC is twice of OA. That is the relation between BC and OA. All right. Next thing, prove that the angle AOB. So which angle? Angle AOB. So where is angle AOB? This is angle AOB. This one is angle AOB theta. So this angle we have to prove it to be 3 pi by 4. So in order to find the angle between two complex numbers, we know that argument of u by v, right, is equals to argument of u minus argument of v, isn't it? So now AOB is made up of u and v, isn't it? The complex number u and v, that is OA and OB. That is what they have asked. Prove that the angle is this, right or not? So from here I can say argument means what? Angle. So argument of u minus argument of v. So we have already calculated that before. That is theta equals to 3 pi by 4. That is the argument of u by v. So this theta is nothing but argument of this v, which is this theta, right? We need to find this. So this complete is the argument of a. So argument of u minus v is nothing but the angle AOB, which is equals to argument of u by v. Therefore, argument of u by v we have already calculated in the part 1, which is nothing but 3 pi by 4. Hence proved. Moving on to next question. We have let f of x is equals to e to the power 2x plus 1 divided by e power 2x minus 1 for x greater than 0. The equation x is equals to f of x. So we are given with this e to the power 2x minus 1 has one root denoted by a. Verify by calculation that a lies between 1 and 1.5. So students, we can cross multiply this and we will get x into e power 2x minus x is equals to e to the power 2x plus 1. So e to the power 2x minus e to the power 2x is equals to 1 plus x. Right, taking e to the power 2x terms to one side. Now I can take e to the power 2x common. So I'll get x minus 1 equals to 1 plus x. Therefore, e power 2x, I can write it as 1 plus x divided by x minus 1. Okay. So now here we know that if we plug in few values of x, we need to check the sign change of these functions, right? So let's check the sign change of 1 plus x divided by 1 minus x. So if I plug in 0, right, put x equals to 0, we have 1. So 1 plus 0 divided by 1 minus 0 is 1. Okay, at 1 it is not defined, right? Put x equals to 1, it is not defined. So 2 by 0 is not defined. Therefore, if I put a negative number, right? If I put minus 1, right? So at x is equals to minus 1, we have 0 divided by 2, which is 0. Okay. Now, if I put a positive number, which is greater than 1, right? Let's say 1.5. So I'll get 1 plus 1.5 divided by 1 minus 1.5. So this is 2.5 divided by negative 0.5, which is nothing but negative 5. So there is a sign change from what? 1, right? At 1, it is not defined, and 0, it is 1, right? So from 0 to 1.5 and 1, it is not defined, right? So from 0 to 1, we can say from 0 to 1, right? The sign is positive. After 1, sign changes, isn't it? So the sign changes after 1. You can see from here. Therefore, we can say definitely A lies between 1 and 1.5. Again, I'll explain. Put x equals to 0, we got 1. The sign is positive of the function. Then put x equals to 1. It is not defined, right? For all the values of x between 0 and 1, again the function is positive. But if I put x equals to minus 1, we get 0, right? So 0 is neither positive nor negative. But if I put x is equals to 1.5, what we have? We got minus 5. So the sign of the function changes, it becomes negative. Therefore, from here we can confirm that the root lies between 1 and 1.5. Okay, students. Now, what we have to do is use an iterative formula based on the equation in part A to determine A correct to 2 decimal places, give the result of each iteration to 4 decimal places. All right. So here, all you have to do is we got x is equals to e to the power 2x plus 1 divided by e to the power 2x minus 1, right? So iteration 1, I can write I1, put x is equals to 1, right? So what we will get this function, we'll get e to the power 2 plus 1 divided by e to the power 2 minus 1. So this value is 1.31. Now iteration 2, put x is equals to 1.1. So e to the power 2 into 1.1 plus 1 divided by e to the power 2 into 1.1 minus 1. This value you will get 1.242. Okay, at 1.2 now, iteration 3, put x is equals to 1.2. You will get e to the power 2 into 2 plus 1 divided by e to the power 2 into 2 minus 1, which is equals to 1.19. Okay, so here you can see that at 1.2 you're getting 1.19, which is very close, right? Which is very close to 1.2. Okay, so therefore we can say alpha is or a is equal to 1.2. The root is 1.2. Okay, so that's your answer. So left hand side is approaching 1.2. When x is 1.2, right hand side function is approaching 1.2, isn't it? So the solution is 1.2. Moving on to next one, we have to find f dash of f of x, hence find the exact value of x for which f dash of x is equals to minus 8. So we have f of x is equals to e to the power 2x plus 1 divided by e to the power 2x minus 1. So f dash of x, we have to apply u by v rule. So u by v rule is v as it is, differentiate u minus differentiate v, u as it is divided by v square. Okay, this is question 2. So we will keep e to the power 2x minus 1 as it is. Differentiation of e power 2x plus 1 is 2 into e power 2x minus differentiation of e to the power 2x minus 1 is 2 into e power 2x into e power 2x plus 1, whole thing divided by e to the power 2x minus 1 whole square. All right. Now this thing is equals to minus 8. So we have f dash of x is equals to minus 8. Therefore, we can write this 2 into e power 2x, I can take it common. So we get e to the power 2x minus 1 minus e to the power 2x minus 1. See, if you take 2 into e power 2x common, you'll get e power 2x minus 1 minus of e power 2x plus 1. So divided by e to the power 2x minus 1 whole square. This thing is equals to minus 8. All right. So here I can cancel this. So minus 1 is minus 2 into 2 is negative 4 e to the power 2x divided by e to the power 2x minus 1 whole square equals to minus 8. Now you can make an equation. We have minus 4 into e to the power 2x equals to minus 8 multiplied by the square of this e to the power 2x minus 1 whole square. So you'll get minus 8 into e to the power a square minus b square is a square plus b square minus 2ab minus 4 into e to the power 2x. So rearranging this equation, we will finally get 2 into e to the power 4x minus 5 into e to the power 2x plus 2 equals to 0. Now you can put y equals to e to the power 2x. Okay, if you do this, we'll get the quadratic as 2 into y square minus 5y plus 2 equals to 0. So if we solve this, we will get the common factors as 2y square minus 4y minus y plus 2 equals to 0. Or we can say 2y common, so y minus 2, y minus 2 minus 1. We get y equals to 1 by 2 and we get y equals to 2. Okay, now since y was e to the power 2x, therefore I can write e to the power 2x is equals to 1 by 2. Okay, and e to the power 2x is equals to 2. So e to the power 2x is equals to 1 by 2 will not be a solution because e to the power 2x is a positive number. It will always be greater than 0.5. Okay, for x greater than this. So now I can take e to the power 2x is equals to 2. Okay, now if I take ln both the side, so I'll get ln 2. So this will become 2x ln e. The power will come in front equals to ln 2, right? Therefore, ln e is 1. So we finally have 2x is equals to ln 2, or from here I can say x is equals to ln 2 divided by 2, which is nothing but 0.346. And that's a solution for x. Okay, moving on to next question, which is equation 10. The diagram shows the curve y equals to sine 2x cos square x for x greater than equal to 0, lesser than equals to pi by 2, and its maximum point is m. Using the substitution u equals to sine x, find the exact area of the region bounded by the curve and the x-axis. So I need to find the area under the curve. For that, what I can do is I can take a small strip whose length is y, but width is elemental length dx. So what is area of rectangle y into dx? Right, L into b, integrating from 0 to pi by 2. This is what I need to do. Now, what is y? Y is sine 2x into cos square x dx from 0 to pi by 2. So now I can write, since sine 2x is what? It is 2 sine x cos x. This is the identity for sine 2x. So I can write here 2 sine x cos x into cos square x into dx, right? Under the integral 0 to pi by 2. So now 2 I can take outside, 0 to pi by 2 is the integral. Now this becomes sine x into cos square x is nothing but sine x into cos cube x. So sine x into cos cube x we got sine x into cos cube x dx. Now I can substitute t is equals to cos x. Therefore, dt by dx, if I differentiate both the side with respect to x, I'll get negative sine x dx. All right. So now sine x dx can be written as what? This dx will go here. I can write it as dt. So dx into sine x can be written as dt. Cos x is t, so this will become t cube and then minus 2 outside. Okay. Now we have to change the limits of t as well, right? 0 to pi by 2 is the limit of x. So therefore, t is equals to cos x, right? So when x is equals to 0, we have t is equals to 1 because cos 0 is 1. When x is equals to pi by 2, we have t is equals to cos 90 is 0. So minus 2 from 1 to 0 t cube dt. Now here the lower limit is greater than the upper limit, right? So we cannot integrate like this because the upper limit has to be greater than lower limit. So now this minus is there. If we change the limit, we have to multiply the integral by negative. So I can take this negative inside and I can write minus 2 into minus 1 and change the limit from 0 to 1. Okay, this is the property of integral. So this minus into minus becomes positive 2 under the integral t cube dt. So now answer for this one is integration of t cube is t power 4 divided by 4 under the limit 0 to 1. So 2 into 1, if I put 1 power 4 divided by 2, which is 1 by 2, right? 1 by 4, sorry, this is 1 by 4. So 2 into 1 by 4, which is 1 by 2. So the answer is 1 by 2 square units. This is the area. Now it says find the exact x coordinate of M. Okay, so maximum point means what? Dy at this point. At this point, what is 0? The slope is 0. Dy by dx is 0. So we have to find the coordinate of M. So at M, dy by dx is equals to 0. So what is dy by dx? Y is equals to sine 2x into cos square x. So therefore we have dy by dx is equals to, here you have to apply product rule. So product rule says u as it is, differentiate v plus differentiate u, v as it is. So we have sine 2x into derivative of cos square x is 2 into cos x into negative sine x plus sine 2x derivative is 2 cos 2x multiplied by cos square x. Now equate dy by dx to 0 to get the critical point. Okay, so what we can write from here is this thing becomes this whole thing 2 sine x cos x can be written as sine 2x. So sine 2x into sine 2x and a negative sign because 2 sine x cos x is sine 2x. So here we have plus 2 cos 2x cos square x equals to 0. All right. So now I can write 2 cos 2x into cos square x is equals to, if I open this, I'll get 4 sine square x into cos square x. Okay, sine 2x is 2 sine x cos x, sine 2x is 2 sine x cos x, so it will give you 4 sine square x cos square x. I can cancel cos square x cos square x. Now 2 cos 2x in terms of cos 2x in terms of sine is what? 1 minus 2 sine square x. Sine 2x identity equals to 4 sine square x. Now if I open this, I'll get 2 minus 4 sine square x equals to 4 sine square x. And therefore, if I take this minus 4 sine square x here, I'll get 8 sine square x is equals to 2, or sine square x is equals to 2 by 8, or sine x is equals to plus minus under root 1 by 4, which is nothing but plus minus 1 by 2. Okay, so we have x is equals to sine inverse 1 by 2 and x is equals to sine inverse minus 1 by 2. Clearly minus 1 by 2 will be ruled out because x is in first quadrant, so x is positive. You can see here x is in first quadrant, so x is positive, right? So we can rule out this. So sine inverse of 1 by 2 is nothing but 30 degrees, which is pi by 6. Okay, so pi by 6 is the correct answer. Now you can divide this thing and write final answer in terms of radians as well. Okay, so I hope students you got the basic idea of all the questions. Thanks for watching.